everyone, welcome to Math Talk. I'm your host, Brian Heisler. And today we're going to look at another method of how you can solve systems of equations. If you haven't seen the video yet on using the substitution method to solve systems of equations, I recommend you check that out. If you have, then we're going to go ahead and look today at how to use the elimination method to solve systems of equations. So let's get started. The elimination method is a process where you are going to either add or subtract the entire equations together in order to eliminate one of the variables. Something to keep in mind as we go through this process is that you may actually have to multiply one or both of your equations by some number in order to be able to eliminate the variable. The goal is that in order to eliminate a variable by adding or subtracting the equations, the coefficient has to have the same number. It doesn't matter if one's negative and one's positive, but they have to be the same number. So let's look at a couple of examples on how to use this method. So I have this system of equations below. It's 2x plus 3y equals 8 and 15x plus 3y equals 21. So right away I notice that the y term, the coefficient for the y terms are the same. They're 3 and 3. And that's great because what that means is I can use elimination to basically eliminate the y variable and then solve for x. And then I can use that x value to solve for y. So because they're both positive 3, I can go ahead and actually subtract these two equations. And when I do that, what happens is 2x minus 15x is negative 13x. 3y minus 3y is just nothing, it goes away. And 8 minus 21 is negative 13. So now I have a one-step equation. I can just divide both sides by negative 13 and I get x equals 1. So I have one of my solutions, x equals 1. What I'm going to do is I'm going to go ahead and take that value and I'm going to plug it back into x in one of my equations. I'm using the top equation just because the numbers are smaller, so it should be easier to use. And I'm going to go ahead and see what happens. When I substitute 1 in for x, I get 2 times 1 plus 3y equals 8, which is just 2 plus 3y equals 8. And so I just have a couple of steps of algebra to solve for y. I'm going to subtract 2 from both sides, and that leaves me with 3y, and then 8 minus 2 is 6. Now I just need to divide both sides by 3, and I get y equals 2. So the solution for this example is the point 1 comma 2, or x equals 1, y equals 2. Okay, so that's one example. Let's look at another on how we can use elimination. I have a system of equations. It says negative 14x minus 2y equals 40 and 8x plus 4y equals 20. So in this system, none of the coefficients for the variables are the same number. The x's are different, the y's are different. However, if I look at the y coefficients, the negative 2 and the positive 4, I know that 4 is a multiple of 2. And so what that means is if I were to take my top equation and multiply it by 2, then the y terms would be the same. They would both be 4s. You know, one would be negative, one would be positive, but they're both 4. And so that's what I'm going to go ahead and do. I'm going to actually multiply the whole top equation by 2, and then I'm going to use the process of elimination to solve the problem. So when I multiply that top equation by 2, I get negative 28x minus 4y equals 80, because I'm multiplying every term in that equation by 2. And then the second equation stays the same, but now I know, again, like I said, my y coefficients are both a 4 of some kind, one's positive, one's negative. So I know that if I go ahead and add those together, a negative 4 plus positive 4 cancels out, so I can eliminate the y term that way. So if I add the two equations together, negative 28x plus 8x is negative 20x. Like I said, the y's go away, and then 80 plus 20 is 100. Now I just have one more step, divide both sides by negative 20, and I get x equals negative 5, which is one of the parts of the solution. All right. Now what I want to do is I want to go ahead and take that negative 5 and plug it back into x in one of my equations. I'm going to use the bottom equation, again, because the numbers are pretty small, and so it should make it a little bit easier to solve. So when I do that, I'm going to rewrite my bottom equation down here, 8x plus 4y equals 20. I'm going to go ahead and substitute substitute in negative 5 for x. And what that means is I get negative 40, which is 8 times negative 5, plus 4y equals 20. I'm going to use a couple of steps of algebra. I'm going to add 40 to both sides. It goes away on the left. I get 4y equals 20 plus 40 is 60. And then I'm just going to divide both sides by 4, and I get y equals 15, which is the second part of the overall solution, which is the point negative 5 comma 15, or x equals 5 and y equals 15. So I hope this helps as you get to looking at solving systems of equations using the elimination method. Again, what you want to look for is if the coefficients of one of your variables are the same. It doesn't matter if one's negative or one's positive. As long as it's the same number, then you can use elimination. You're going to add or subtract the entire equations together. Keep in mind, though, that you may have to actually multiply one or both of your equations by some factor or some number in order to get the coefficients of one of your variables to be the same. I recommend just go ahead and choosing one of the variables that you want to eliminate, and then multiplying your equations accordingly to get them to be the same number. Be on the lookout for my next video as I look at how to solve systems of equations that are presented as a word problem. Not every time are you going to have an example that's just given to you as equations. You may have to create your equations using word problems and then solve. And so that's what that next video is going to look at. I hope everyone's staying safe, and as always, thanks for watching.